So as you come through this door, I'll take your tickets from you, finally. Holding on to those for so long. And you can grab a lantern, really from anywhere.
Don't put it on SOS, we'll have a seizure.
You got them.
It's crazy that they can make the flame turn on and off.
So you all are going to be going down in a section of the cave that we don't bring as many people to. All right. Follow me.
This is totally a Balrog needs
I
to come
was just
here.
gonna say when
Like a distant glowing red light.
Freak everybody out.
All right, so first things first, let's turn our lights out. Just need to give some perspective here. If you have any light from the phone or camera, be sure to put that away.
Yours is
Any
on the
little bit of
wrong,
light's gonna
wrong way.
kind of spoil the phone. So here we go. So if you put your hand up to your face, can you see it? Just have some fun looking at the cave, maybe learning a little bit about it. And so we're going to do a little short walk here. Get used to the walking conditions. If you look behind you, you'll see some ribbon on the floor, some rocks piled up, as if to keep you out of some spot, and that's exactly why they're there.
Oops, mine's flashing stuff.
In Kentucky?
Yeah, Kentucky.
So what ingredients do we need for a cave?
water.
Water. Yeah, it's very important. What else? What surrounds us?
Rocks.
Rocks. Yeah. Really, those are the two main ingredients that you need, water and rocks. A third very important ingredient, though, is time. And not just any time, but geological time. Geological time is simply a vast amount of time that we really have a hard time comprehending because of our rather short lifetimes and perspectives based on that. So over geological time, everything you see here is formed through the interaction of water and rock. So this rock here formed at the bottom of a shallow sea that used to exist over much of North America about 450 million years ago. Now this is a very long time ago, again kind of hard to imagine, but North America was actually south of the equator at this time, looked nothing like it does today. But there were sea creatures that lived in that shallow sea, and as they died, their shell and skeletal remains would become a part of that soft ocean bottom. And they pile up over millions of years, compress the layers below it into the rock that we see here today. So specifically, this rock is limestone. How many of you have heard of limestone before? Mm-hmm. Yeah, it's one of the most common rocks on the surface of the earth because it forms at the bottom of the oceans. Continues to form today. But limestone has a unique relationship with groundwater and with any sort of solution, any sort of liquid that is acidic. So if you were to put vinegar on this limestone, it would fizz. You could see it actively dissolve that limestone away. But groundwater is on the acidic side too, just a little bit. You don't notice it when you taste it, but it's a little bit acidic, just enough to be able to dissolve away this limestone. So after this ocean went away, this was a solid block of limestone. There was no cave for another 449 million years or so. Somewhere around 500,000 to a million years ago, the south branch of the Root River formed, that river that you cross on your way in and out of that parking lot. And as soon as that river formed, water started to go through the cracks that had developed in the bedrock here. Now, water is always looking for the easiest path downhill, so that water would find those cracks and it would move through it a lot easier than it would the rest of the bedrock, and in many cases easier than it would along the surface. So water would move through those cracks, and as it did, it dissolved them into gaps, and those gaps, where the water continued to flow through in high volumes, would eventually become the passages that you are all walking through here today. So that is the reason that these passages are here, and the reason that we're able to walk through them. There was once an active stream, river, flowing through these passages here, probably at the time of the last glacial melting period. So glacial meltwater would come through in very high volumes compared to today and create these passages over still a long period of time. So which direction, if you had to guess, do you think that stream was moving? Any ideas? It was going that way, yep. So the springs, if you were a droplet of water flowing through that river, you'd eventually come out to daylight about a half mile downstream from here through those springs. Now that would be only after about 7 hours since you sank in the bedrock through that river. So the river water is moving through very quickly through these passages beneath us. Only about 7.5 hours total for it to get from one side to the other, which is remarkably fast, even for water on the surface of a river. Almost goes at about the same rate as it does on the surface. So, pretty remarkable river. Not the only river that does this, but it is one of the largest ones that does this in this area. All right, so now that you have that kind of in mind, any questions about the formation of the cave itself? Passages? So we'll go for a little longer walk now. I want you to pay attention as we go to the shape of the passage, to the texture of the walls. We're going to go into a little more detail on what's going on there.
Yeah.
So up on the ceiling here are a couple of bats point out. Don't want to disturb them too much, but just so you can see them there from the back. One right there and another one kind of tucked up here. So they look to me like two little brown bats, which is actually a name, common name for the species, little brown bat. Not very creative, but but that's what they appear like to me. It's our most common species, one of 4 that hibernates inside of Mystery Cave. And they are just down here hanging out. We'll be leaving later on this evening for an evening of feasting on what? What do they eat?
Insects.
Insects. Yeah, they can eat up to their weight every single night in insects.
Wish I could do that.
So they eat a lot of them.
You do that.
Now, if those bats lived in the cave all the time, meaning they went outside to eat, but then they came in year-round to rest, they would be digesting and leaving behind a lot of bat guano. And for warmer caves where bats do this, that's what kind of sets up the whole cave system for more of an ecosystem of critters that can survive the darkness and the conditions down here, like we experienced back when we had our lights off. So that's when you get blind salamanders, blind fish, things that have lost their eyesight, but can survive in that cave all the time because the bats are bringing in a food source nightly in the form of their droppings. Because we have so few bats that come in here in the summer, we really don't have much for food down here, and therefore we don't have a lot of living things down here. There are a few very small invertebrates that will hang out in the cave their whole lives and are adapted somewhat to it. But most things that come into Mystery Cave have to go out in order to find something to eat. It's a great place to hibernate down here. That's when we tend to see more critters in the cave, although we're out of the cave here too, so we don't see them, but we see signs of them. All right, so how about the texture of the walls here, the shape of the passages? What have you noticed?
Very color.
Yeah, they're kind of pitted up here, right? You see these holes up here? These are the fossilized burrow of a marine worm that used to exist in that soft ocean bottom. So this is what's called a trace fossil. A trace fossil would be something the animal leaves behind, not their bodies themselves. Another example of a trace fossil would be a footprint. Now here is a real fossil, not a trace fossil, I should say. This is the fossil of a creature called a cephalopod. Cephalopods have long spiral shells. This one probably tapered off to a point within the rock here, and then out the other end were a bunch of tentacles and a pair of black beady eyes. So at the time that this creature roamed these oceans, this was a top predator. So this is before the evolution of fish or sharks. And this creature lives on today in the form of squids and other related members of that family. But it had a hard spiral shell, and that's what's fossilized here. So coming farther down, you see even more texture in the walls here, not just those worm burrows, but also some bubbly formations on here. There are some actual cave formations. We'll talk more about those up ahead here, but these are a formation called cave popcorn that typically forms in pools. So these pools, or this suggests that there was a pool at one point here. Now there's also some signs that water moved very swiftly through here as well. That kind of scalloped appearance on the wall, where you have kind of the crescent-shaped features and patterns, suggests that water was moving very swiftly. Limestone is generally very resistant to erosion, but under the right conditions, especially if that water is filled with rocks and other things that can scour some of that rock away, it can erode as well. And then finally, see these big slabs of rock up here? Where do you think those came from? Up there, right? Up from the ceiling. Can you imagine rocks of that size falling all the way down from that ceiling, landing on this ledge, and not continuing to tumble down onto the cave floor beneath? Doesn't seem likely, right? What do you think happened? What's going on? How come those rocks are perched up there?
Water left in there.
Say again?
Water left in there as the water levels decreased.
Okay. Yeah, I think you're onto the right thing there. What was happening, or I should say, what happened is when these rocks fell, the floor of the cave was way up here. Now those rocks look like they could have fallen yesterday, right? They got sharp edges. That gives you an idea of how little things changed down here. We don't know of any major collapse down here since the cave was opened up. So the cave that you see here today looks identical to the cave that the first explorers saw down here. All of the collapse was probably happening when there was an active stream flowing through here and when there was a lot of flooding going on. So as those glaciers melted, water rose up to the ceiling there. It would saturate the rocks up on the ceiling. So you don't think of rocks absorbing water, but they do. They act a little bit like sponges in that way. And water's heavy, right? So those rocks up there get added weight to them from that water, and then the water also acts a little bit like, it's denser than air, and so it gives them a little bit of buoyancy up there as well. So as soon as that water would start to drain or disappear farther down, leaving those up suspended there, the extra weight and the less dense air would cause them to collapse. So we're seeing a lot of the collapse on the floor here that happened probably 10,000 years ago or more. So we have been down in what's called the Stewartville Formation of limestone. Anybody know where Stewartville is? Stewartville, Minnesota? Just south of Rochester. Maybe you drove through it if you were coming from the north. That is where this layer of rock with all the worm burrows was first described in science. So layers of limestone that have similar characteristics are grouped into formations. We are going to be in two formations today right now. We are in the Stewartville Formation, and in just a moment, we're going to be heading down this way and climbing up a little bit higher into the bedrock, and we'll be in a different formation. So keep your eyes peeled. I'll kind of ask you what has changed once we get up there. So how have things changed now? What are your observations?
A lot of rock slabs.
Yeah, a lot of breakdown up here.
Closer to the ceiling.
Yeah, we're closer up here to the ceiling. It's a little bit smaller, shorter ceilings.
No more of those little pits and
Yeah, where'd the worm burrows go? No more worms.
Ceiling's also very wet.
Yeah, it's very wet up here too, right? Does the floor feel a little different? It's sticky. Yeah, yep. So all of those observations caused reason to develop, in science anyway, a new rock formation to describe this one. This is known as the Dubuque Formation, named after Dubuque, Iowa, because that's where it was first described in science. Now Dubuque is pretty far away from here, right? So this layer of rock exists way over beyond Dubuque even. So these layers of rock span far and wide along the Midwest here. Now this Dubuque layer has very distinct layers of limestone. You can see layers of limestone separated by layers of shale down here. Now shale is a different type of rock. It's hardly a rock though. If you picked up a piece of shale, you could pretty much rub it away with your fingers. There's not a whole lot of, rockiness to it. But that shale is what kind of impacts the passage here enough to make it look a little bit different in shape and texture even. All this water is coming because that shale is there. The shale does not let water go through it very easily. It's made up of very fine particles that are cemented together. Whereas beforehand, coming from the Stewartville layer, water could move through vertically very easily. So this water, the water that's moving through the rock, encounters that shale as it goes downward and is forced out. And that is why our walls are wet here and glistening. You can even see suspended droplets of water up on the ceiling here, all the way down. How about the shape of the passage? How's that different?
It's narrower.
Yeah, kind of boxy shaped. Not quite canyon-like like the other one. So those layers of shale allow a little bit more breakdown to form. As that ceiling breaks down, it would have landed into the ocean, or not the ocean, the river water, and that river water would dissolve it away slowly. But at the time that river was here, it was probably well underneath this breakdown, moving through that rock, slowly lowering the breakdown as it dissolved it away, almost like a conveyor belt, except dissolving it. So layers of shale indicate a change in ocean depth. So oceans have risen and fallen in the time that it took to deposit this limestone here. That shale being made up of much finer particles suggests the ocean rose quite a bit or advanced onto the landscape even more so. So a lot going on up here just in the characteristics of the rock. We are going to take a little short, narrow passage right down here into an adjacent passage that runs parallel to this one. It's even a little bit bigger. Any questions before we move on? All right, so follow me. All right, so this parallel passage is even a little bigger than the one that we left. We're gonna be coming to some of the biggest passages in the cave. Right up ahead here, we'll be going up and down a little bit, using some stairs made from rock found within the cave. I ask that you pay close attention to your footing as you go up and down these stairs, especially if you've been sliding around. Really depends on the rubber of your shoes as to how well you grip the surfaces down here. Once about half the group gets up the other side, I'll have everybody stop right where they are for a moment, just so that we can kind of take in the scenery a little bit. With all our lights being spread out, it's kind of a good photo opportunity too, as they illuminate the passage that we're going through.
Do you want to be in front or behind you this time? How about I go in front of you so you can hold on to my shoulders if you have to. Okay. Hand on my shoulders. Okay, steps. Good.
All right, if everybody wants to stop right where they are just for a moment, take a look around you for a little bit. All right, carry on. So we've been talking mostly about passage formation, and we're going to switch gears now and talk a little bit about cave formations. Cave formations form from groundwater seeping into the cave. That groundwater has dissolved a little bit of limestone on its way down, but then the interesting thing is that it deposits that limestone again as part of a mineral called calcite. And that calcite is what creates all of these cave formations, even though they take on a lot of different shapes. Now we mostly have a big mound here of what's called a flowstone. So flowstone looks as though it's floating because it's being formed by that water that's flowing right over the surface here, depositing that calcite. Those that hang from ceilings, that you can see on here, those are called what? What are they called?
Stalactites.
Stalactites, yep, so stalactites are tight to the ceiling. Stalagmite would be formed from the bottom up, usually on the receiving end of that droplet of water. We'll talk about and see some stalagmites up ahead a little bit farther here on our way back out. Now this calcite, or those stalactites I should say, they will grow maybe an inch in 100 years. So while it is new rock forming right before our eyes here, it still takes that geological time for it to happen. So a long time for those to grow. Just 1 inch, although that is pretty fast nonetheless. So all of the water here that's creating this flowstone is bringing us to Blue Lake, which is the largest pool in the cave, right up ahead here.
Oh, wow.
Whoa. Oh my goodness. That's so beautiful.
Lake fluctuates a lot with seasonal rainfall. Last year during the drought, it was completely dried up down here. The first time I'd seen it like that. But this year, by contrast, it actually overflowed its banks, which was about 4 feet higher than it is now. Not quite up to the bottom of the bridge, but pretty close. So if you look, you're going to see the sheen on top of that water with some little rafts floating around. Those rafts are rock. So if you didn't think rocks could float, even very small rocks, here we go. We have some floating calcite. The water in this pool is so saturated with dissolved limestone that it can't hold it anymore. And that calcite crystallizes in such a way that allows it to float on the surface. Now, if a droplet of water keeps dripping from the ceiling in the same place, it's going to sink that calcite in the same place over and over. And that calcite then piles up on the floor of the pool, forming these cones here. So these cones are called raft cones. And they're a fairly unusual formation. Mystery Cave is known in the caving world for its raft cone formations, which you get to see here. So the lantern and geology tours are the only tours you get to see raft cones on. Or I should say the scenic tour you don't get to see them. You do actually see them on the wild caving tour as well. Any questions about Blue Lake? Raft cone formations or any formations? All right, so we're going to move on. Our big passage is going to get a little smaller and a little smaller as we go along.
You guys are crouching down and your heads are never hit.
All right, so we're going to trade our nice, wide, spacious passage for a length of narrower passage. This is called the Diamond Caverns. It's called that because there are crystals of gypsum inside that flash and sparkle back at you down here to some degree. Diamonds is certainly an exaggeration, but nonetheless, a neat little passage. This goes for about 200 feet or so and then opens back up into a room. The ceiling starts out low, but then most of you will be able to stand upright at least at some point on our way there. So enjoy, and I'll see you on the other side.
Oh gosh, I'm so yeah. Hey, it's okay.
You might have to get on your hands and knees, Dad.
Everyone called it
I don't really have to duck that much.
I don't have to duck because I'm shorter than my mom.
Yeah, so if you belong to a caving club, you can get a permit to come in here simply for exploration.
Oh, wow.
So trying to, usually involves digging new areas out. You can kind of see some of that digging right here. Typically, if you move loose rock and mud, that's acceptable in terms of cave ethics. Blasting, not so much.
Yeah.
Right? Chipping away at solid bedrock, that's generally not acceptable. But there are
Does that
certain,
happen a lot? Like, are there a lot of groups that do that? Or not really?
I would say not a lot.
Okay.
Yeah, not very often. Kind of the heyday of cave exploration seems to be from 1960s, 70s, 80s. It's waned a little bit. We think we have found most of the passages that people can get through
Okay.
in this cave system. There's certainly more to be discovered, and there's certainly more cave we know that is out there based on where we see water flow where it sinks and where it ends up as springs. So we know there's more of Mystery Cave out there. We just haven't really found a way into it from these existing passages. So, all right. Look behind me here. You'll see a railing. Maybe you recognize that on your way in. We're going to be going down a ramp there and making our way back out. So even though we're going through familiar passages, we'll still be seeing new things. Your lights will be pointing in a different direction. We'll be traveling in a different direction. And we'll stop and look at one of those things. So take your time going down that ramp. I'll wait for everybody to get down it. If you've been sliding around, you're going to slide around here too. So use that handrail.
Having fun, Chloe?
That's a moth. There's a couple of flies on here too, and I don't know what kind of moth that is, so I'm taking a picture of it to try to ID it later on.
Where?
But typically near the entrances, I'm pointing out to right there.
Oh, yeah, there he is.
Yeah, there's a few of them up here. But near the entrances, you tend to get more insects coming in, hanging out. I don't know if they're waiting for night to fall or what, but yeah, there's another one right there. Just looking at some insects up ahead here on the walls that are just like that bat, hanging out for a short time before they go back out. So one feature you may have missed on the way in shines a little bit more light onto some of these stalagmites and how they form. If you think about water dripping down onto the floor of the cave or really anywhere, say under the eave of a roof, what do you observe or what do you imagine seeing that water do? If you look around, you're going to see on the floor some holes, right? That's where drips are, dripping down from the ceiling. So just like outdoors, that water will drill a hole into the ground. And what's neat here is that this flowstone that formed over some mud, along with these stalagmites, that mud got washed away underneath, and that flowstone is able to hold it all up and give us some insight into these stalagmites. So sure enough, what look like stalagmites on the surface that are just starting to form here have actually been forming for a long time. You can see that initially the water droplets that created those stalagmites drilled down into the mud beneath. And eventually that calcite was able to take over and withstand the pounding action of the water dripping from the ceiling and build its way back out to the surface. So what looks like stalagmites that have just started to form from the surface here have actually been forming for a very long time. All right. So, the time now has come to end our tour and for you all to find the way back out. I'll take up the rear. Those of you in the front or anywhere really can try to find your way back out.
That's you, Sam.
If you come across a first aid kit, you've gone too far and you need to turn back around. But once you have found the passage that leads to the stairs, you can climb up those stairs, hang out in that first room that we started out in, and wait for me to come up and then
Right here, Chloe, we go up here.
Yeah.
We're in the moment.
I want to go in there.
That's great.
first aid.
No, that's not. Oh.
Yep, they were right. It's that way.
That's awesome.
We found the first aid kit. It's down there. Thanks.
Yeah, and that way it's so long.
Okay, I see a person. Hello. I saw him.
Oh, Chloe, would it be scary if they did a Halloween theme and had like
Things don't go out here.
oh, what a temperature change. Yeah.
Thank you.
You're welcome.
Thank you.
Yeah. All right, so the river level.
Very different. Well, the scenic tour, you would have had seen more.
Oh, that'd be cool. I wanted to ask him what that one all entails.